So today we will explore how structured methods like A3 thinking and the 7 basic quality tools can transform how we tackle um, our problems like a scientist. So here is what we are going to cover today. So we will start with what makes problem solving scientific? Why does it need to be scientific? And then we will dive into the A3 thinking, the PDA cycle, and the 7 basic quality tools. A quick test of your knowledge with a chance to win 1 month access to our Kaizen Academy courses, and a certificate in distinction in problem solving is going to be provided towards the end of this session. And also stick around for a Q&A session and a special offer that's exclusive for the webinar participants, tailored for the continuous improvement professionals that we are going to reveal towards the end of the session. Um, we recommend you to stay until the end of the session because you don't want to miss out this exciting opportunity to elevate your skills and drive your impact. So, scientific problem solving is about identifying the problem that we're trying to solve and its context, identifying the current target conditions, analyzing the problem or the opportunity based on facts, building a solution based on solid grounds of facts and proper analysis, and also testing these solutions and checking if they produce the required target condition. It's not about filling like a piece of paper and that's it, or using the tools that we're familiar with, but it's rather a mindset and a way of thinking towards solving the problems on hand. Um, Let me first ask you a question. Have you ever encountered a situation where you later realized that you were solving the problem in an ad hoc manner? So you were supposed to solve a specific problem, but you found out that you're just randomly thinking of solutions or causes without using a methodology or a scientific approach. A yes or no is sufficient, or sometimes is also good. Yeah. Anyway, we are all fallible, so we're subject to our biases, but at the same time, we want to make sure that whenever we try to solve a problem, we're solving it in a way that will help us overcome these biases or tending to find the answers before understanding the problem properly. Thank you so much. Um, A3 thinking, developed by Toyota, is a mindset and a tool that helps you document problems and solutions on a single sheet of paper of what is known as the A3 size. So the A3 is coming from the paper size of A3, which is double A4, the usual printer paper size, and it's about clarity, collaboration, and continuous improvement. Integrating A3 methodology into team activities help companies stop avoiding problems and view them as opportunities for learning and development. The A3 methodology promotes a scientific approach that encourages individuals to observe, present data, propose solutions, and adjust based on results. It serves as both a problem solving tool and a structured process for developing skilled problem solving. Um, as we mention here, a scientific method that includes um, observe, use of data, proposing countermeasures, checking, and adjusting. What does that remind you of? I'd like to ask you to think what is the approach or the methodology that follows these steps, and it consists of 4 letters. So what is that methodology or way of thinking? Yeah, observing, using data, proposing countermeasures, checking and adjusting. Exactly, that's BDCA. Thank you so much. So the BDA cycle, or the plan, do, check, act, is a cornerstone of A3 thinking. So the whole methodology is designed to reflect these four steps. It's it is like the scientific method for problem solving. So you plan your hypothesis as a scientist, you test it out, and then you evaluate the results, and then you adjust. This iterative cycle ensures that learning never stops. So the PDCA, the Plan, Do, Check, Act cycle consists of four steps. The first is plan, where you identify the problem, set process goals, and outline necessary changes. And you think of this as a hypothesis. This is something that I would like to test. And then do, and in doing, we basically trying or testing our hypothesis. So we implement the proposed changes or the new process, and we are actually here conducting the experiment practically. The third is check, where we evaluate the results and reflect on what was learned. And finally, act, which is integrating the learning into the new process, standardizing the change, and repeating. And if the results were not achieved, we now can adjust again and repeat the cycle until we reach the level that we would like um, to reach. You can loosely translate hypothesis like a theory. So you have a theory about what what should be happening in order to, or what should be changing in order to um, um, improve, for example, the product quality. So, for example, you will say, I have a theory or I have a hypothesis that if I change the temperature, the or the speed of the machine by X percent, this will result in improving the product quality. So it is um, this is what we mean by a hypothesis. An A3 typically includes the problem background, the current conditions, root cause analysis, countermeasures, and follow-up actions. And the precise format of the template or of the A3 template is flexible, and most organizations tweak the design to fit their unique requirements. And it's not the format of the report that matters, but underlying thinking that leads the participant through a cycle of PDCA, Plan, Do, Check, Act. And the seven tools that we're going to discuss today would help us in identifying the current conditions, the goals and targets, analysis, and many other aspects of the A3. We are going to discuss later today which tool can be used in which part. Let me show you something interesting that you can use um, to build your A3. So something like this, if you can see if you can see the screen right now. So here we have a template that includes the key components of an A3. So it would include the background, the current condition, goals, analysis, proposed countermeasures, plan, and the follow-up. Okay. And and again, as I said, you can use this template as the starting point to exercise the A3 methodology in a template. But as I said, it's and as I'm going to show you, like you can have different ways of or different templates or different structures, but they are all revolving around the idea of plan, do, check, and act. Um, by the way, this template, which is part of the scientific problem solving course templates, I'm going to share with you this template and the templates that we are going to use today. I will share it with you in the after meeting email with the recording and also with these key resources. I'll share the presentation as well with you after the session. So this is a template that you can customize or change or brand it as you wish in your own organization. So this is an example of um, an A3 that is already like filled out. So here is we have a value stream mapping exercise or a project. So we have the background, the current condition, the analysis, the goals, and so on and so forth. And as you can see here, it has like now it looks something um, uh, like you can see here. It has a specific layout, and in another exercise, it could be having a slightly different layout. So you can adjust it as you learn and as you feel more confident, you can adjust the template as per your liking or as per the use case. But again, you have to follow the PDCA. You need to think of your solutions in a way that reflects the scientific um, uh, thinking mindset. I'd like to highlight that the A3 is more than just a tool. It represents the mindset and it encourages ongoing learning and development. And it fosters collaboration among team members, enhances communication across different levels, and drives continuous improvement within an organization. By adopting the A3 thinking, individuals and teams can systematically identify problems, analyzing root causes, and developing actionable solutions. This approach not only enhances efficiency but also creates a culture of transparency and collective problem solving, leading to a better outcome and more engaging workforce. As you try to scientifically solve any problem, you will need at some point in time to use some tools to analyze or to understand the problem on hand. And this is why we are going to talk today about the 7 basic quality tools. So, the Japanese professor Kaoru Ishikawa, who also developed the fishbone diagram. So, I think most of us are familiar with the fishbone diagram. It's also called Ishikawa diagram or the cause and effect diagram because it was developed by Professor Kaoru Ishikawa. So he played a key role in the development of the 7 quality tools and the concept of quality circles during the quality movement in Japan in 1960s. And because quality control was often perceived as too complicated for many workers, companies turned to these straightforward tools, the 7 tools that were accessible for everyone to learn and implement. So the idea behind the 7 quality tools was to make them or make the quality improvement accessible to everyone. So the 7 basic quality tools are the histogram, the cause and effect diagram, check sheet, Pareto diagram, graphs, control charts, and the scatter diagram. Um, its tool, each tool has its own unique purpose, and you shouldn't be pushing these tools into the problem that you're trying to solve, but to pull these tools as you need them. So you don't just to use as much of these tools as you need, and like the idea is not about the use of the tools, but selecting from the tools the ones that are relevant to your problem. So, for example, the cause and the effect diagram it helps with discovering the root cause of the problem, allowing to find the correct solutions effectively. Um, the graphs would help us understand the trends, relative importance, and so on and so forth. We are going to discuss each of these tools briefly today, but we are going to focus a little bit more on the histogram and also on the Pareto diagram. By the way, we're going to have like a an a, a Q&A session towards the end of the session. So please be ready with your questions toward the end of the session. Thank you. So the first tool that we're going to discuss is the histograms. And the histograms are perfectly um, usable for visualizing the data distributions as they help us on identifying the patterns and the variations in a process. For instance, you can use a histogram to assess the product weights in manufacturing, and also using the histogram, it will be easy for you to find the shape, the central value, and the manner of dispersion of, for example, a product weight. And consistent quality depends on such insights. And to develop a histogram, you will need to pass through 4 stages. Um, Calculating the range and identifying the number of classes, calculating classes and frequency in each class, and then drawing the histogram. Okay, so just for example, the range is the difference between the minimum and the maximum value. For example, here we have some data that reports the thickness of a specific product. And we, in order for us to understand the performance of our process and how consistent our thickness is, we need to see this in like this table is not helping that much, right? So we need a visual way to represent the distribution of the thickness. So, for example, if we build or if we followed these 4 steps, we can build that histogram in this in a way, and it will look something like this. And um, and you don't need to like once you understand the logic behind how to build a histogram, then you can use like any template that can be, or templates that will help you build the histogram in an easy way, in an intuitive way. So, for example, here again, I'm going to share with you the template to this to the histogram. So for example, we have here a template that we can adjust, and we just fill in the data here, and it will build the histogram for us based on the data that we provide. Okay, so it will adjust automatically according to the data that we provide. Um, I think we would agree that by using um, this visual histogram, are in a better position to understand the performance of your product or process. Just this is much better than just reading the data in a table or having a list of data. So, for example, here we can easily judge that most of the thickness that we produce is something between 3.43 and 3.55, and um, rather than just relying on the table that we just saw before, right? This is much easier. And I would like to ask you, um, and I would like to ask you that whether you have used before the histogram in your own area of work. Have you used histograms before? Okay, some used, some not. Okay, and as I said, you don't need to use the histogram in every exercise, but as I said, you it's important to learn its use cases and how to use it, so that when you encounter a situation in which you want to use it, you know that you can use it, and then you can implement it. Um, you can also read and use the histogram using many methods. Um, so once we draw the histogram, it's not the end of the story, but we want to get some insights out of it. So one way to look into the histograms is um, um, by understanding the shape of the distribution, and by understanding and by this we can understand many aspects related to our process. So, for example, we can from the histogram we can understand what is the most common values. As we could see in the previous slide, it was easy for us to say, okay, from that range to that range, most of our process is producing that thickness in most of the cases. How great is the dispersion? So we can see like what is the minimum value and maximum value, and also is the distribution symmetrical? So it looks like this, so it's mirrored kind of. So right, like if we draw like a virtual line from the in the middle, is it um, similar to the right and to the left, or is it kind of skewed in a specific direction? Or do we have one peak like this, or we have multiple peaks like this? In other words, you can, by understanding these uh, questions, you can understand the characteristics of your product and your process. Another way to look at the histograms is comparing the histogram to the specification limits. So, for example, we now can determine from the the histogram, once we have put the lower specification limit and the upper specification limit of the product. So this is the target thickness of the product. Then we can know, for example, that we have 3% out of our products are out of specification limit. The average of our performance is 3.48, but the target should be 3.44, and that we have a dispersion that is too high. Okay, so this was the first tool, which is the histogram. The second tool is the fishbone diagram, the cause and effect diagram, and it's also known as the fishbone or the Ishikawa diagram, as we highlighted earlier. And this tool helps you identify the root causes by categorizing the potential factors, and it's invaluable for understanding why issues occur and where to focus your effort. Um, we're going to cover into details how it is built, but I would like just to check with you. Did fishbone diagram help you in the past with problem solving? Let me see your responses in the chat. Yes, together with the five whys. By the way, we did have a specific webinar for the five whys and the fishbone diagram. We are happy to share with you the recording of that webinar as well after the meeting. Um, so the key benefits of the fishbone diagram is it serves as a like an educational tool for all participants, and it shows us how well we understand the process, and it helps with identifying the root causes, and it can be used for any problem regardless of its nature. So it could be related to quality, productivity, cost, and so on and so forth. The third tool that we can that we're going to discuss today is the check sheets. And check sheets um, are very handy, especially in the shop floor use. So when preparing a histogram, for example, to collect a great deal of data and then first, and then use a software to build the frequency distribution or to draw the diagram um, um, from the table and to do the entry. Sometimes it's a kind of double task. So um, it can be sometimes easier to in many applications to use the check sheets to record the data and analyze it at the same time. So for example, we can prepare a template like this, and here we have the range of thicknesses, for example, and as you measure every product, you can just use tallies or the check marks to say, okay, I have one 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 reading here, one reading here, one reading here, another reading here, and then eventually you will find yourself have already established a histogram, right? Um, without the need to use any kind of software um, 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 or a computer, and it will be easy for you to know without further analysis that we have these many products outside of the specification limits, and then you can adjust your process accordingly. Of course, there are tools or there are systems that can be used or found and used to automatically draw these graphs on the fly, but um, um, sometimes it's not necessary to do such an investment to have these dashboards because like simple tools can achieve the same results. So if you don't have it already, you don't have such systems already in your product lines to draw these kind of graphs or dashboards, you can use the check sheets templates for your workers to record their own performance and also to understand the variations whenever they occur. The fourth tool that we're going to discuss is the Pareto diagram. And the Pareto diagram, um, it's in a Pareto diagram, it's much easier to see which defects are most important um, than just to read this um, in a in a in a tabular format. So in a Pareto diagram, um, we can using this Pareto diagram we can say, okay, I need to focus more on the. So these are the list of issues, and these are the frequency of each issue, but they are sorted in a descending manner, and the line graph shows the cumulative percentage of occurrence of each of these issues. So by using this diagram, we can know easily that the our first priority should be targeting this issue, caulking, and then connecting, and then gapping. And it tells us that if we just tackle the first cause, which is caulking, it can help us reduce 50% of the defects or issues. Um, because it forms the tallest bar. And using the Pareto diagram generally follows the 80-20 rule that 80% of problems often comes from 20% of the causes. By focusing on the vital few issues, you can achieve significant improvements, and it's a game changer for prioritizing actions. Um, to draw a Pareto diagram, um, or by drawing the Pareto diagram, you will be able to define priorities for improvements. You can build a common understanding of priorities and defining weights of causes and tackling results. Again, as I highlighted, you can, once you understand the logic behind the Pareto analysis, then use tools or templates like this one, which would in which it will be easy for you to draw and adjust um, the readings as you go along. Um, so another and as I said, all of these templates are included in our scientific problem solving course, but I will be sharing with you after this session the template for the A3, for the histogram, and the Pareto, along with the slides, of course. So how do I draw the Pareto diagram? So first you identify um, the classifications, like what I'm trying to solve, and then identifying the time range. So you'll identify a specific time range, and then you would sum up the each classification um, for each cause, and then you would calculate the cumulative percentage as you go along. And then you draw the bar chart from the highest to the lowest, and I drew the line chart over the bar chart by using the secondary vertical axis. And then you will use the percentage to identify target classification. For example, if I want to uh, if I want to target 75% of the problems, I will start here at 75, and then I will go this way until I hit the line, go horizontal until they hit the line, and then I will go down. Now I know that if I want to reduce 75% of the issues, I should be tackling these three issues, and these can become like secondary afterwards. So we've covered the histogram, um, um, the fishbone diagram, the check sheets, the Pareto, and then we'll now are going to talk about the graphs. Um, And the graphs include many tools such as the line chart, bar chart, and pie charts, and they simplify data representation and they reveal trends and relationships at a glance. And it helps with spotting issues quickly by visualizing your data. So, for example, we have here, like this is an example of a line chart. Um, and this is an example of the bar chart. And as you can see, the histogram and also the Pareto are special cases of a bar chart. And also you can use the pie chart in order to, uh, for example, represent the relative percentage of specific or of specific um, factors. So, for example, here we have like um, a relative contribution of supervisors, workers, others, and staff. And by this, we can easily know that, like, for example, supervisors contribute to 58% of the contribution of for example, in this case, in the um, quality circles. The sixth tool, and as I said, of course, we're not doing the justice to describing every tool in this quick webinar, but it helps with, or this is just an introduction, and we're going to share with you some resources that you can rely on, and also we have a specific course that is dedicated to every tool of those in a more detailed manner. Um, so the control charts monitor process stability over time, and they are essential for identifying the variations and maintaining consistency. And by using these, you can ensure processes remain within an acceptable limit. Um, do you use control charts now, or you used them before? Did you ever use control charts, or you currently use them? Okay. X bar R and X bar and R control charts are just one example of the control charts that can be used. And um, uh, but basically this one reads the average or performance, and also the this one reads the range of our data in a specific um, time or a specific sample. We are covering the control charts in more details in our course, scientific problem solving course, and maybe later we can have a dedicated webinar for the control charts. The last tool that we're going to discuss today is the scatter diagrams. And the scatter diagrams, we basically have two kind. We plot two kinds of data where they are indexed and plotted on an ordinary graph. And from this chart, you can, for example, know that as the um, that we have a correlation between the moisture content and the uh, elongation percentage, and so we know that they are increasing together or decreasing together. And the correct reading of the scatter diagram must lead to proper action. And it's so you need to be very careful on how you interpret any scatter diagram. So, for example, we have here what is called the positive correlation. So, as x increases, y increases, or as y increases, x increases. Um, uh, Here we have also a positive correlation, but it is not as strong as this one because they are kind of forming one line or a solid line. This is not a very solid line looking. And also here we have a negative correlation. So negative correlation means as x increases, y decreases. And also this is another example of like a weak correlation, but it is negative. And here we have no correlation at all. So how can we use these seven tools in our A3? As you can remember, we said in the beginning that these seven tools can help us with developing our A3. So this table outlines the typical sections of an A3 report, linking each section with suitable tools like the graphs and fishbone and so on and so forth. It helps present information effectively in our A3, aiding process improvement and project management. So um, to get you started with A3 thinking, you need to take some factors into consideration. Don't stress about whether you're using a pen or a pencil or a computer program. Just start, and then ensure that you have a sponsor for each A3 that you do. Educate all the stakeholders involved. Um, use sorry about this, and use it as a standard tool for problem solving. And also, I can't stress this enough. Always ask yourself, what is the problem that I'm trying to solve before starting an A3 exercise. Now we have a quick competition. Um, um, I'm going to ask you to join this quick competition that I believe you will be enjoying. So there will be a certificate of distinction in problem solving given to the top three performance, and also 1 month access to our scientific problem solving course that includes all the details of all the tools, and also templates and downloadable PDFs and so on and so forth. Um, um, Along with the other courses that we provide. But this will be limited for 1 month access, but you will have unlimited access to all of our courses. And the best performance for this competition is going to be based on the fastest and most accurate answers. Please note that there is a limitation to participation, so please join as fast as you can. I'm going to share with you how to join this exercise. participate in this exercise. So you can um, um, use this QR code um, by your phone, and then you will be able to join. Good. So I can see people started joining. I also share the link to this in the chat as well. I will allow just 1 minute for others to join. As I said, the best performers will have the opportunity to uh, have will get a certificate for distinction in problem solving, and also three and also access to our courses for free for 1 month. So the highest scores are for quickest and accurate answers. So question number one. Sorry. Which phase in the PDCA focuses on trying a solution? So do is the phase that we use to try. So plan, do, check, act. Do basically means try. Question two. What is another name for a cause and effect diagram? Is it scatter plot or Ishikawa diagram or control chart or histogram? Okay, that's right. Ishikawa diagram is the right answer. Next question. Hmm. Percentage of problem usually stem from a few causes according to Pareto principle. That's right. What percentage of problems? It comes from um, 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 usually comes from few causes, 80%. So you focus on 20%, you get to 80%. Which tool is best for monitoring process stability over time? Control chart. Control chart is the right answer. Who pioneered the 7 basic quality tools? Is it Edward Deming, Ishikawa, Taylor, or Ford? Kaoru Ishikawa, that's right. What is the main purpose of a histogram? Relationships, data distribution, prioritizing tasks, or collecting data. That's right, visualizing data distribution. Next question. What is the first step in an A3 thinking process? Background is the right answer. Thank you. What does PDCA stand for? That's an easy one. Exactly, that's Plan, Do, Check, Act. The last one is a bit tricky, but you will have more time to answer it. Given the data set, which of the following statements is true? You have 1 minute to answer this. We didn't cover what average is, median is, mode is, but if you know the answer, please answer. Mean is the average, median is um, the value in the middle of the data when it is sorted, and mode is the most common value. So the right answer is 10, 10, 10. Um, so only a few got it right, but thank you so much. So let's see who were the best performers. Nice. So Earthman, Frosty, and Beyonce, uh, or Beyonce. Please, for the first three or the best three performers, Earthman, Frosty, and Beyonce, please share your emails with me, your full name and email in the chat, because I want to issue the certificates for your proper name. So just um, share here in the chat. So Earthman equals um, John, for example, and this is my email, and so on and so forth, so that I can issue to you your certificate properly and share with you um, the access to the course. So congratulations for everyone, and go- and uh, uh, and thank you so much for contributing to the exercise. Um, Please drop your email for the three winners. Please drop your email for confirmation. Um, okay. Um, Lastly, I would like to in the few last moments to cover two things. The first is um, um, the offers that we're going to provide throughout this webinar, and also to answer a few questions that we received. So Imagine mastering these scientific problem solving principles and tools and the other fundamental learnings necessary for you to develop your lean, Kaizen, and operational excellence knowledge and skills. And also at the same time, um, earning a recognition as a lean manager. Our exclusive program, coaching program, offers personalized one-to-one coaching with online learnings, industry insights, and certification. And this is your chance to unlock your full potential and lead a transformative change as a lean manager. So this program is designed to empower both aspiring and experienced managers with the skills, strategies needed for operational excellence and continuous improvement. This program is designed to empower you with the key tools that you actually need in order to develop your continuous improvement career and get a certification as a lean manager. Um, so I'll give you a glimpse of the key benefits that you get out of this coaching program. So you will have 12-month access to all of our courses, self-paced courses, and these courses are designed to provide you with the flexibility and to learn at your own pace, ensuring that you fully grasp the lean principles and tools. And also, you will have unlimited access to our personal development library. So this library includes more than 200 courses about personal development, data analytics, business skills, and also one of the standouts of this coaching program is our one-to-one personalized coaching program, coaching sessions, and this would be focusing on the lean principles and tools, including the scientific problem solving that we discussed today. And these sessions will be tailored only for you individually to address your specific knowledge needs and required skills, ensuring that you get most out of the program. Also, you will, if you enroll in the program, you'll also have a lifetime premium newsletters and industry updates and sessions like this one, but more advanced, um, to get access to the best practices in lean management. So once you enroll in one of our coaching programs, you will have unlimited live access to key benefits. And exclusive sessions. And also you will be guided in a capstone project with coaching in order to finish your project and in order to improve your capability to exercise and implement lean tools and methodology. And finally, you will have the final exam and get your badge and certificate as a lean manager. So these are examples of the courses that we have as one of the benefits. So we already have the scientific problem solving course, value stream mapping course, and Toyota production system. And also we use this framework in order to develop a personalized experience in your coaching. So we will focus with you on the key tools and principles that are relevant only for you. Um, and after the completing the program requirements, you will be officially accredited as a lean manager from the Kaizen Academy. And these are the requirements in order for you to get this certificate.